Hey, what's up? It's Jake, and I had an interesting scenario come up today with Amazon DocumentDB, and so I figured I'd do a quick overview of it so you can find out what it is if you're curious and a little bit of how to use it. So this is all going to be in the AWS Management Console, and there will be a follow-up video after this with cloud formation if you're looking to do this native to AWS. So, what is DocumentDB? Well, it's a document database. It's really just think MongoDB. I took all the documentation and I condensed it heavily. So hopefully this is much shorter than reading it yourself. So it's super easy to set up. It's completely managed service. You can use the same Mongo drivers that you use with MongoDB. So there's not a whole lot of application code you need to change. Really, it's just like database connection strings. So it has auto growth up to 64 terabytes. You can do up to 15 read replicas, scale up and down really, really quick. It runs in a VPC, shared or private. You can configure the firewall however you want. It does auto start on failure. Unlike a relational database, it does not do redo logs, and it has an isolated database cache. So it's a totally separate process. There's an automated failover to any one of your 15 read replicas in other availability zones. There's backup retention up to 35 days, which is backed by S3. And you can enable encryption with KMS. So let's talk about the cluster architecture. So when you create a document DB in AWS, you're actually creating a DocumentDB cluster. And so the way this works is within a region, you have your multiple availability zones, and your cluster has a cluster volume. And the cluster volume is just your backend data storage. And you have 2 copies across 3 different availability zones, which gives you 6 total copies. Super redundant, very, very, very good, very durable. So operationally, what you have is you have a primary instance, and this is an actual EC2 instance. So you choose an instance class, whichever one meets your CPU and memory requirements. And you can use the same or you can use different, up to you. So you have a primary, and it just reads and writes through data copies and has a front end cluster endpoint, and you would use that to connect either directly with Mongo Shell or with your application, like with an API or something like that. You also have the option to do read replicas, and you can do them in multiple availability zones. And the read replicas also have an endpoint, a reader endpoint, that you can use for analytics or any kind of queries that are read-only in nature. Those are automatically replicated with the data copies that are being written by the primary instance, as you can see here. And so it's a pretty standard, just kind of like highly available RDS type instance that you would expect to see at AWS. So the instances can have multiple databases inside them. So if you're not familiar with how that data structure works, is you have a database cluster, and inside of there you'll have databases, and a single database has one or more collections, and a collection has one or probably very, very large number of documents. And the documents are all JSON objects, um, and it's a completely NoSQL kind of solution. And like I said, compute memory determined by instance class. Like I said, it's a regional resource, spans multiple availability zones. Pricing is pricing, it's pretty standard. Monitoring, CloudWatch, you can do DocumentDB events to CloudTrail, and then you can access it via the console, CLI, Mongo Shell, or with your application via MongoDB drivers. So how does it work? So first thing you do is you create a cluster. It has 0 or more database instances and a cluster volume that manages the data. Like I said, it spans multiple availability zones. And also I mentioned it has a cluster volume and then your instances, so primary or read replicas. And that's kind of the relationship. So you got your endpoints, your compute layer, and then your storage layer. Cluster instances can be different instance classes. So like if you have an analytics engine that needs to go to a very specific replica and you need that replica to be a lot bigger, then you could have that option. We'll get to that when we talk about sets. So your endpoints, cluster endpoint is what you use to get to the cluster, reader for read-only traffic, and then instance endpoint. So in the instance like over here, like I said, if this was an analytics um, database or data source, then you might have an instance endpoint where your analytics application points to this instance specifically, not just to the reader endpoint, so that it gets the advantage of being able to utilize a larger instance class if it does need something like that. The other thing you can do is create replica sets. And when you use this set mode, by default, this whole replica set here is names rs0, replica set 0. You can specify read concerns, write concerns, read preference options, and connect the cluster endpoint to a set mode. You basically just use the same string, but you declare you're using rs0. TLS is supported. I'm not going to cover it. And by the way, that is the default, the rs0. That is the recommended way to connect to your database. For the storage, all the storage, like I said, it's in a cluster volume. It's all SSDs, 6 copies. You can grow it. You're only billed for what you use. If you delete something, you're only billed for what you use. The overall space might stay the same. So if it does grow and it gets up to like 64 gigs, but you're only using 40 gigs, you're not being billed for 64. And if you do some kind of archive project and you get down to 20 gigs, you're still being billed for 20 gigs, but your actual available space is still going to be 64 gigs. Just worth knowing. Don't be alarmed. The reliability, service auto repair. So all the volume segments from the storage are automatically repaired if there's any issues, which is why there's so many copies. Survivable cache warming refers to having a separate process from the database. So if the database needs to restart, your cache is persistent and your queries will be queued in that cache until the database becomes available and can process them in kind. There's crash recovery, which uses parallel threads to make it a lot faster, and resource governance that kind of goes along with cache warming, and that even when it's not in a failure state, it will request during high memory load and throttle things so that your standard performance and expectation of that, how the application behaves, is consistent. Read preference option, you can give any of these primary preferred, secondary preferred, or nearest to you options for how you want people to get to reads. And then lastly, you have TTL deletes, which is the time to live. It'll delete from an index, but depending, it's best effort. So depending on what's going on with the database, if it needs resources, it might wait and for things to slow down before it starts adding extra work. So just know that that's kind of a best effort, not guaranteed at a specific time. Okay, so let's check this out. Make sure you have an AWS account. You have the Amazon DocDB full access IAM role. That is the full access role. You may not in production want to give that much access. And a VPC. And if you don't have one, you can use the default VPC. That is fine. So let's go through the steps. So first thing I'm going to do is I'm going to use Cloud9, which is not something I use very often. And you're just going to create a Cloud9 instance. Like I already have one. Apparently it failed to delete, probably because I had it open. So let's create an environment. So we're just going to name this demo Cloud9 environment. Okay, next step. And you're going to leave all these as the default and all these as the default. Make sure your VPC is default. Next step. And a review, create environment. Cool. So now I have a Cloud9 instance to write in. So now, next thing you're going to want to do is create a security group with a custom inbound TCP port of the MongoDB port, which is 27017, with Cloud9 security group as the source. So when you create Cloud9 instance like this, it creates a security group. Now this does take a few minutes, but we can go ahead and get the security group started in the meantime. So we're going to come down here to security groups. You can get there from EC2 or networking. And we can see I have 2 security groups here. And one of them was recently created, and I'm not exactly sure which one. So it's going to be this guy. So let's just change this name really quick to delete me. so I don't use it because I have to clean up. All right, so this is the one we want. And we can see it ends in 01D, C01D. All right, so we're going to make a security group, and I'm going to call this demo docdbsg and allow 27017. This is my default VPC. Add an inbound rule, custom TCP port. Port is 27017. The source is going to be our Cloud9 demo, but it's going to be the security group any member in C01D. This is the one that's created by Cloud9 when it creates the environment. And we're just going to say MongoDB access for Cloud9. Outbound is fine. We can go ahead and name this if we want. So name demo docdbsg. Create the security group. And BAMSys, we are up and running. There it is. So now you have a security group. You go to the third step, create a DocumentDB cluster. Make sure in the advanced settings you do select the new security group that you just created. Sweet, so let's open another tab. And we're going to go to DocumentDB. And we're going to create a cluster. I'm going to leave all this as default, except I'm going to make this instance size much smaller because I don't, T3 medium, don't want to get billed for it. And I'm only going to do one instance because I don't need a gigantic cluster. If I wanted to, I could do multiple. If you really want to see it, like I could do, here's 3 instances. You can see it. Auth, admin, and document are reserved names. So use something else like demo db user. And then I'm just going to give it a password of password demo db user. Remember that. Advanced settings, make sure you're using your default VPC. And security group, we're going to get rid of that one. And we're going to pick our new one that we created, which was demo documентdbsg. That's the one we just created. All this other stuff can stay the same, although you can disable deletion protection so we can delete it later. Create cluster. This takes a few minutes, so you're going to want to wait for this to happen. So I'll go ahead and pause the video, go ahead and catch up if you need to, and I'll come back when it's ready. All right, so my Cloud9 environment is ready. I'm still waiting for my cluster. So while we're waiting for that, I'm going to open a new terminal here. And in this terminal, we're going to run 3 commands. First, we need to create this repo file. So I'm going to copy this sucker, and I'm going to paste it into here. Done. Then we need to install the MongoDB shell. Copy, paste, yum install MongoDB org shell. And we can wait for that to finish. And then the last thing we need to do is get this PEM file. This is a very important step, so don't forget it. Paste, enter, and now I have a PEM file. There it is. Okay, so the next thing up we can do is we can connect to the DocumentDB cluster. There's a connectivity and security tab, so you just click on that, and then we're going to copy and paste the second string that you see. Okay, so I've got one instance up, so we can go ahead and see if this works. So let's try our connection. And connection failed. I'll just keep waiting. Okay, finally finished. Took a while, but I'm in. So if you see this RS0 primary, that means you did it correctly. So even after they're all available, you'll see this. It still takes a few minutes to get the DB up and running. So now we're going to do some testing. So I'm going to insert this hello DocumentDB object, this document, into a collection. So let's try this. Collection.insert hello document DB. So we should get the right result n inserted 1. And now we can read the document by going db collection find 1, and we can see this object ID with a hello DocumentDB. So that's working. So now we want to create multiple profiles. So these documents, I'm just doing a name of a person, whether active or inactive, what level they are in a video game, and what their score is. So we'll go ahead and paste this. True inserted 1, 2, 3, 4, which is true. And then let's find the profiles that we're using. So I'm going to go ahead and paste this. And we can see all the records match what we inserted. And notice that Matt has a score of 202. So we're going to try to isolate this. So first, let's look for Katie. So DB profiles find, and we can find Katie. So you can query individual values, or we can modify them. So we're going to take Matt, and we're going to increment his score by 10. So he's got 202 now. And if we increment his score by 10, and then we find the profile for Matt, you'll see he now has a score of 212. So that worked pretty good, right? All right, so now we're going to do backup. So if you have backups enabled, what you're going to find is over here, you're going to see snapshots, and you'll have a snapshot. And it is set to excuse me, do this automatically. But we're going to make a manual one. I'm going to show you why. So we're going to create a snapshot identifier. So I'm going to go demo doc db dash snapshot. And I'm going to create this. So it's going to go ahead and create. And while it's creating, I'll explain why I'm doing this. So when you delete a cluster, it'll delete all the snapshots identified with that cluster as well that are created by the system. Any manual snapshots created of a DocumentDB cluster is actually retained, and you have to go back and delete it manually. So the reason I want that to happen is I'm going to delete this cluster, and then I'm going to show you how to restore a cluster from a snapshot in the event that you need to do that, either for example, you want to change regions, or you want to recover from some sort of disaster or whatever. Anyway, so this takes a while, so go ahead and pause the video and go get some coffee. So I went ahead and updated this to run my profiles.find command one more time so we can just double check the data, and we can see here Matt has a score of 212. So I went ahead and exited, and as soon as this snapshot is completed, we'll make a new we'll delete this database, this cluster, we'll delete this cluster, and then as soon as it's done deleting, we will make a new one from restoring the backup, and then we'll run the same db.profiles.find command, and we should see all of our data. All right, my snapshot is available and progress is completed. So now I can go ahead and delete my cluster. So I'm going to select this cluster, actions, delete, create a final snapshot. No, I acknowledge that it's automated backups, including system snapshots, point in time recovery, no longer available. So I'm going to say delete entire cluster. Delete. And away we go. And then it's kind of new, so they want some feedback to know why you did this. I filled it out once, but I'm not going to fill it out again. So we'll just wait for this to finish. Actually, instead of waiting for this to finish, let's go ahead and go to snapshots. We're going to select this snapshot action, and I'm going to restore. So while the other one's deleting, we can make a new one. Again, I'm going to pick the tiny one, T3 medium, minimum number of instances. Let's just do 1 so it doesn't take as long. And then advanced settings, I got my default VPC, get rid of the security group, and I want my demo doc DB DG. That was a typo. That should be SG. Same port, same encryption, nothing. I can name this if you want to, and this is fine. I'm going to turn off enable deletion protection, and I'm going to restore the cluster. And you can see what this looks like. All right, so now I've got these ones deleting and I've got these ones creating. So we'll just keep updating this. I'm going to wait for the cluster to become available. The instance will take a little bit longer, but what I'm looking for is an endpoint. So when we click on this, here we go. So I'm going to copy this guy. I'm going to go back to Cloud 9, clear, and I'm going to paste this, and I'm going to change this to just my password. And if you run it now, it's going to be like host not found because the instance isn't up yet. So if you get host not found, it's because your instance is down. If you get the connection timeout, it probably means your database is still creating and it needs to wait a little bit longer. Okay, my database instance is available and I am logged in. So let's go ahead and grab this command. And with our recently created restored cluster, see what we find. And here we see Matt. It's a score of 212. All of our records are in here and we are good to go. So that is a basic overview of what a document database is, what DocumentDB is, how it works, features, benefits, how to create one, how to connect to it, how to add stuff to it, modify, all that stuff, as well as taking a backup manually and doing a restore. So that should be pretty much everything you would ever need in DocumentDB. The only thing we didn't go over is subnet groups, which it creates automatically. In the default, you can choose to put it like in a private subnet, for example. And then it's just regular VPC networking after that. The other thing you can do is create a parameter group, which is another option you can get into in more advanced stuff. And then set up event subscription events, CloudTrail, all that stuff. So if you have any questions, let me know. But if not, hopefully this was helpful. And for you people that actually use DocumentDB, good luck out there. And I wish you all the best.